Myself, C. Sivakumar, working as Assistant Professor in Mathematics at Dr. N.G.P Arts and Science College, Coimbatore. In this lecture, we are going to see about sequencing problem in operation research. In this video, we are going to see about what is a sequencing problem, basic terminologies in sequencing problem, then how to find the sequencing problem of the type n jobs are to be proceed on three machines A, B and C in the order A, B, C. That is, first on machine A, second on machine B and third on machine C. Finally, we calculate total elapsed time and ideal time with example. Okay. First, definition of sequencing problem. The selection of an appropriate order for a finite number of different jobs to be done on a finite number of machines is called a sequencing problem. The sequencing problem is to determine the order or sequence of jobs to be executed on different machines so that the total cost time involved is minimum. Next, basic terminology. In the following, we describe the basic terminologies which are commonly used in job sequence. First one is the number of machines. It refers to the number of service facilities through which a job must pass before it is assumed to be completed. Next, processing time. This is a time recorded by each job on each machine. Next, processing order. This refers to the order or sequence in which machines are required for completing the job. Next, ideal time on a machine. This is a time duration which a machine does not have a job to process. Next, total elapsed time. This is the time interval between starting the first job and completing the last job, including ideal time if any, in a particular order by the given set of machines. The last one is no passing rule. This means that the passing is not allowed. The same order of jobs is maintained over each machine. If n jobs are proceed through two machines A and B in the order AB, then this means that each job will go A first and then B. Next, example. Sequence of problem of processing n jobs through three machines. Okay. Here, there are 5 jobs, namely 1, 2, 3 and 4, each of which must go through machines A, B and C in the order A, B, C. Processing time in hours are given below. Find the sequence that minimum the total elapsed time required to be completed. Jobs 1, 2, 3, 4, 5, missing A, missing B, missing C. Okay. In this problem, there are 5 jobs and 3 machines with processing time are given. Okay. Solving this problem, we use Johnson algorithm. First, we convert 3 missing problem to 2 missing problem. For this, we add missing A and missing B with the processing time and put a new name, likewise H.G. Then we add another 2 machines, here missing B and missing C. Add these 2 machines and put a new name Okay, so in this purpose we add machine A and machine B. That means we add also processing time. In here processing time for machine A and machine B, we add this value, we get 5 plus 2 7, 7 plus 1 8, and 6 plus 1 4, 6 plus 4 10, 9 plus 5 14, 8 5 plus 3 8. Likewise, we add these two values and put new name. Finally, we get job 1 2 3 4 5. We add A and B, put a new name G. So we get these processing time 7, 8, 10, 14, and 8. Then second missing H, it will come adding two jobs, two machines B and C. The processing times in the order 5, 8, 9, 11, and 10. Okay, so here we converted from three missing problem to two missing problem name G and H. Okay. Next we going to find optimal sequence followed by Johnson algorithm. So, okay, in Johnson algorithm, first identify the smallest processing time in all the processing from all the processing uh, time. Okay, and suppose the smallest processing time is in first machine, we write the job from left to right. Suppose it is in second machine, we write the job from right to left. So we can use in this order. Okay, here the minimum time is the minimum time is 5. The minimum time is 5 in job 1. So we write job 1 is from right to left because of job the minimum time is in second machine in H. So we write 1 is here from left to right and remove the job. Next, second smallest value is 8. 8 is in 3 places. Okay. First, we take the 8 in job 2 in first machine. So write job 2 in from left to right and remove the job 2 row. Next 8 is in job 5. It is also in first machine. So the job 5 is entered into next of job 2 and remove this row. Okay. Then identify the next smallest value. Here 9 is the next smallest value in H. That means second machine. So write the job 3 in left, right to left, that means next to 1 and remove that row. Finally we write the remaining job 4 is in center. Therefore we get the optimal sequence is 2 5 4 3 1. Okay, okay, next we construct a table and first column we write the jobs sequence 2 5 4 3 1 and machine A, machine B, machine C, and time in, time out of machine A, time in, time out of machine B, time in, time out of machine C. Okay. First, we enter time in of machine A is 0. That means in starting point the machine is in ideal. So time is process time is 0. Okay. Next, timeout is in time out of machine A is first the job 1 is going to proceed. So the value of, that means the processing time of job 2 in machine A is 7. So enter 7 in timeout of machine A. Okay. Then this 7 goes to time in of machine A, and in this stage the processing time of job 5 is 5. So 7 plus 5 is 12. Next, it goes to time in of job 4. In job 4 the processing time is 9. So 12 plus 9 is 21. Then 21 goes to time in of job 3. In job 3 the process time is 6. So 26 plus 6 is 27. So 27 goes to time in job machine A. In machine A the time processing time for 1 is 5. So 27 plus 5 is 32. Okay. Next we move to machine A. So machine A in time in is 7, because after complete the job to work the output values goes to input of machine B. So time in of machine B is 7. Okay. Okay. Next, in job 2 for machine B, job 2 plus machine B the processing time is 1. So 7 plus 1 is 8. So then the 8 goes to the time in of job 5, but the output of job 5 is 12 hours. The input of is 8 hours. So the greatest compared to these two values 8 and 12, the greatest value is 12. So enter greatest value is in here. Okay. In job 5 the processing time for machine B is 3. So 12 plus 3 is 15. Okay. Then 15 is here, and processing time for output of job 4 is 21. Comparing these two values, the 21 is the greatest value. So enter 21 in input time of machine B. So 21 in machine B the processing time for job 5 is 5. So 21 plus 5 is 26. Then 26, 27, comparing these two values, the greatest value is 27. The processing time for job 3 in machine B is 4. So 27 plus 4 is 31. So 31 and 32, compare these two, greatest value is 32. So 32 is processing time in job 1 in machine B is 2. So 32 plus 2 is 34. Then go to machine 3, machine C. Okay, the processing in time in value is 8 by 8. Then the value of the process time for job 2 in machine C is 7. So 8 plus 5, 8 plus 7 is 15, and right 15 is in here. 15 in job 5 the processing time is 7. So 15 plus 7 is 22. Comparing 22 and 26, the greatest value is 26, and enter in time in value, and 26 in job 4 the processing time is 6. So 26 plus 6 is 32, and the 32 is entered in time in value. In job 3, the processing time is 5, so 32 plus 5 is 37. So 37 enter in job in time in value. The processing time for job 1 in machine C is 3, so 37 plus 3 is 40. Okay, so we completed this table. Next, the overall in overall table, the time the processing is end in 40 hours. So in 40 hours the processing is completed. Okay, that means, and the 40 means the total elapsed time is 40. Okay, next we identify the ideal time for machine A, machine B and machine C. Okay, here the ideal time for machine A is uh, first first A is first total elapsed time 40 minus the output value of missing A in last job. So 40 minus 32 is 8. The total the ideal time missing A is 8. Next ideal time for missing B is first in job 2 there are the ideal time is 7. Next 12 minus 8, the difference of this value is 4. Then 21 minus 15, 6. 27 minus 26, 1. 32 minus 31 is 1. And 40 minus 34 is 6. So adding this value we get the value 25. Next ideal time for missing B. First enter in 8, 15 minus 15, 0, 26 minus 22, 4, 32 minus 32, 0, 37 minus 37, 0. So adding these values, we get 8 plus 4 at 12. So ideal time for missing B is 12. Okay, result. Minimum total elapsed time is 40 hours. Ideal time for missing A is 8 hours. Ideal time for missing B is 25 hours. Ideal time for missing C is 12 hours. Then summary. In this video, we learn about what is a sequencing problem. Then studying basic terminologies in sequencing problem. Then how to solve the sequencing problem of the type N.G.P or to be proceed on 3 missing. Finally, we calculate total elapsed time and ideal time. Thank you.